raise some attention that we all have some responsibility in the research we're doing, and it's really to have a discussion and to make us aware. So again, I'll start with some initial questions that we can think about, and I'm sure there are plenty of others that we could raise. But basically, if we had an AI system that makes an incorrect scientific discovery, who do we hold responsible? Who is going to be blamed for? Who is going to have some legal responsibility or whatever is happening for big discoveries? And yeah, who is in charge? Then we could also think if an AI model is highly accurate, but we don't understand how it works, are we supposed to trust it? Are we supposed to say, oh, this is really good accuracy for all this data, but we don't understand? So do we just publish the results? What do we do? What ethical risk do you see in using AI to make discoveries about space and astrobiology? So this is really an open questions. And if you have some thoughts, feel free to put them in the chat, or we'll have them for the discussion. And if you don't think about it because it's late, I guess it's not that late for you guys. But we can start to think about it for the workshop. I think just having that in mind, like what is a risk? Because there are some. Okay. So I'm Victoria, I told you earlier, I'm working at Goddard and Mass Spec and machine learning, but I'm absolutely not an expert in ethics. Like it's just something I'm interested into, but I have never studied it. I don't know anything about it. So when I put these slides together, in fact, I learned a lot. So thank you for the opportunity, Ryan. And I put some resources at the end with some links that I use for these slides. I think it's a big topic. And I think it's a not easy topic. So that's also why we put a lot of different type of people, astrobiology, machine learning. There are some engineers, there are some doing their PhD, there are some already with their PhD. Like we are a mixed group and a mixed team, so I think we can learn a lot from each other. But I truly believe the question we're trying to work on, and I think we're all agreeing of detecting life and life on other planets or exoplanets is not easy. So bringing the topic of ethics is adding another layer to this not easy subject. And we as a group, as a team, we need to have a careful approach, but I think it's a responsibility we have. We must be careful with these big science questions we're trying to answer, because we're doing a cool job, like trying to find life in the universe, and this is so exciting, but this is a big topic. So we have, I think, responsibility, and maybe I put too much pressure on my shoulders right now and on everybody's shoulders, but I think we have to be careful. So I had some thought about what machine learning and data science can do. So we had great presentation earlier for the people who are not familiar with data science and machine learning. So there is a lot already in our daily life. We have a lot of tasks that can be automated. We trust a lot of decisions coming from that. And it's really starting to be more and more present in our field. In my field is planetary science, but it's in astrophysics, it's astrobiology. So it's more and more there. But because there is also a lot of things that are difficult to interpret sometimes, and it can have some negative impacts. In our case, it's different, but I have an example later of how machine learning can badly impact some situation. And also it has some innate biases based on the data we use and the how machine learning works in general. So I struggled, like when I thought about these slides, I was like, what does ethics means to you? So you can either put words in the chat or you don't have to, but I will have some words coming up after. And again, we can talk in the discussion in the next 10 minutes what you think about ethics. But here is a definition first. It's coming from Greek and then Old French. And the main definition I found was that it's the study of moral principles that govern human behavior, getting what is right and what is wrong. So it's pretty general and pretty vague to me. So I found this picture in Google and I was like, okay, yeah, if I think about ethics, I will think about principles, I will think about choice, I will think about fairness. So I thought it was like words that we might all think about. And I might put these slides again at the end for like, if you think about anything else, I think it might be very useful, like anything else related to astrobiology research, please, that will be very useful, I think, for us to talk about it. So other key aspects of ethics. So I will just go through the animations, but some moral principle, honesty, fairness. In our case, decision making, what is right and what is wrong. It can be like false positive detections for like life detection. That's a big deal. And consequences is how our actions are going to affect people, society. In our case, it's like scientific research, like how saying we found life on another planet is going to impact other research and our field. And also the big question is accountability and the impact. If there is bad predictions or something that is not reliable, what do we do about it? Again, different context, but I think he understood the main thoughts here. For instance, professional ethics, like do we think as machine learning people or AI people, we should have a code like I don't know how you say this word, Hippocratic oath, or some regulations for us to like be careful about the data we use and the algorithm we develop. And then more from a data science and AI ethics point of view, I added this sentence here about the fairness, the bias, the transparency in our applications of machine learning in this field, because we want to make sure that we are good scientists and what we're doing is good science and we are not seeing stuff that do not exist. So again, I put other examples of what if scenarios, but that's pretty similar to what I showed earlier about having an AI system that detects the biosignatures, but the data looks convincing. What do we do if it's coming from an AI? Do we act on it? What do we do? If an AI algorithm suggests that the exoplanet or the target we're studying is habitable for humans, but then we discover that it was wrong, who is in charge? Who is accountable for that? And then if an AI system determines that a target is non-habitable, do we just give up or do we continue investigating? Like these are just questions to be initial questions, and there are plenty others, I'm sure. So I'm excited to hear about your questions. So okay, we have a lot of tools like machine learning and AI are a lot of tools that we have available to study big topics. But to me, I think ethics is not a checklist, and it's just going to be an ongoing discussion when we are doing our research, and we have to understand who are the people in charge, because we are all being like funded by NASA or SETI or other people. So who funds us? Who is going to use the technology? Who is the technology be used on? In our case, not like planets. So I think this is not really something for us, but who are the people in the discussions? Because we have engineers, we have scientists, we have machine learning people. So there is a lot of different languages also, like we are not talking the same languages. And I think it was great to see these previous talks because astrobiology people and machine learning people, we speak English, but we don't use the same languages because we're in different fields. So being able to speak the same language for these big questions is tricky. And I think it's also one of the difficulty for ethics and project development here. So I'll just go. I'm sure you heard about the trolley problem. So I think I needed to put that in these slides. What do we do in this case? Do we pull the lever to divert the runaway trolley and go on the other track? Or if it became a bigger trolley problem, what do we do? Like right, left, straight? So this is the main representation of ethics. What is good, what is wrong, and how do we apply it in our science is I think just for us to be aware of. This one also was, I think, one of the first slides I saw when I typed AI and ethics on Google, and I was like, yeah, do we choose A or B if we have to choose one of the other? So it's something that happens. You might have seen like the cars without drivers. There are some accidents. So who is in charge? How do we make it better? How do we not make it happen? These are questions just to be aware in our field. So when I think about machine learning, and I think we had some discussions earlier, there are some, it can be used for interpreting data. It can also be used for decision-making system. So both of these aspects of machine learning, decision-making process and interpreting the data with some data analysis have some ethics link. And for the decision-making system, it's exactly the example of the trolley problem. Which action do we take based on the situation we are in? For the interpretation of the information, it all requires assumption at some point. Like we need to have some assumption to be able to interpret the data. And sometimes maybe our assumption is biased. In our field of planetary science and astrobiology, it's complex. And that's why I really like, I think it was in Mike's presentation when he mentioned having the unsupervised approach being probably the most, not useful, but the first one to use so that we have less bias and less assumptions in the data. I completely agree with that viewpoint. Okay, so as I mentioned, we have all roles, and we are scientists, we are early careers, we are middle career, and we just all learn something about how we can use AI or in our daily life, in our science, and how we have to understand that we don't talk the same language and that we need to exchange with each other and try to talk about the same problem, even more for these big questions. And I think this is great that Ryan and Caleb are organizing this workshop with really two different types of, or several types of people with different fields, because this is difficult. And having the more people from different fields will, I think, bring a good synergy and create a lot of great answers, hopefully. So one example that I found, it was a slide, I think I didn't put the reference, so I'm sorry for not referencing this slide, but it's in the presentation also earlier, we saw that machine learning models are built thanks to data, and data is coming from our world. Whichever type of data is coming from daily world, or in our case, planetary science missions or exoplanets. But here I took the example of hiring decisions because it's something you can look a lot of news about, like Amazon hiring less women because the algorithm was biased. So in this case, because our data is biased, because the world is biased, then the model will be biased. And so the action we'll be taking on these machine learning model results is going to be biased and will, the worst part, amplify this existing bias. So that's something I think in our field is also going to be tricky because we use the data we have access to. And a lot of things we don't have access to because planetary science and exoplanets is just difficult, and sending billions of dollars of spacecraft is difficult. And I can tell you right now, in Italy, I'm working on an ExoMars mission. This mission was supposed to be launched in 2016. It's 2025, and we're hopefully launching in 2028. So just everything is taking forever. Okay, so in this field of astrobiology, I put really some main problems that I thought about, and I'm really excited to hear about what you think. But really what could be problematic in our field is for biosignature detection is detecting false positives. Like, what do we do about it? Having bias in data sets because we have very Earth-centric biology, so it might be hard to generalize for non-life as we don't know it. And then being able to reproduce machine learning results. And I think it was coming from the last presentation from Stuart. I wrote a note because it's not in my slide, but I was like, yeah, we get one measurement from planetary science missions. What do we do with one measurement? Because how do we reproduce this measurement? Do we get other instruments that can help us? So this is also one of the problems we have, is being able to reproduce our results, I think. So again, we talked a lot about this black box models. So how do we get more transparencies on our machine learning systems? If our machine learning system is telling us there is potentially life there, do we trust it? What do we do about it? How do we explain to our scientists, this is the reason why the machine learning algorithm decided that? So this is something, there are tools now, and I have some list of tools that can be used for transparency and explainability. Then the data we're using is biased. So how do we extrapolate that to other type of models? In my field, I feel it might be different in astrophysics, but in my field, the data is very limited. So I don't have a lot of data I'm working with for like planetary science, mass spectrometry. So the sample analysis at Mars that has been on Mars since 2012, we really don't have that much data. But that's, I think, different in other fields. So yeah, here are 3 examples. I'm sure there are plenty. It was really putting some sites together, and these were the 3 main I thought about, but I'm excited to hear about yours. Here, I will skip these slides, and I will share the slides with you later, but it's all the buzzwords that we have for like transparency and intelligibility, explainability, interpretability. So there are some differences, some nuances, but it's basically to be able to understand why a model took this decision. Here again, some tools that I'm sure machine learning people know for interpretability in machine learning to understand which features are important to make this or that decision. I personally really like just the first one to just the last one, sorry, to take a feature, to remove it and see how it affects the model. I think it's the most easy one to see why and how a feature is important or not in a model. Okay, this is, again, because I'm not an expert, I just try to use all the resources I had to link them so that everybody can use them later. And again, I don't want to be like putting too much weight on our shoulder, but I think we all have a responsibility here to do good and hopefully great science and hopefully Nobel Prize science one day. So we have to be careful about what we do and what we publish and what we say and how we communicate. I think in the slide before, in fact, there is communication discovery and the search for life in the universe. So that link I'll put, I think NASA shared that. I don't remember, but it was a workshop that Mark Neveu also participated to, who is a big life detection scientist at Goddard. And it's how scientists communicate on social media, on Twitter, on X, on whatever platform, big results like this, because we all have a voice and we have also sometimes to be careful how we communicate our science. What am I saying? That ethics and interpretability are important, yet to trust the machine learning applications. I think it's the case in every single field, but probably even more in astrobiology for life detection missions. And this is, again, open and ongoing discussion to make sure we as a team have that in mind for the workshop we'll be working on in February, I guess at the end of the month, and for the white paper we'll be working. That's it for me. Again, I'm not an expert, and it's really based to be a discussion and to raise some awareness here. So I'm excited to talk with you guys.